I'm Saksham Thakur, EC6 Sem, going to represent my seminar on the topic that is Organic Light Emitting Diode OLED. Introduction. It uses organic light emitting diode. It is emerging technology for displays in devices. It offers brighter, thinner, high contrast, flexible displays. Next we have OLEDs are solid-state devices composed of thin films of organic molecules that is 100 to 500 nanometers thick. They emit light with the application of electricity. They doesn't require any backlight, that is, they are self-emitting. They are made from carbon and hydrogen. Next we have the structure of OLEDs. First in the structure we have cathode. Here you can see the first layer as cathode layer. The cathode injects electrons into emissive layer. Next we have the emissive layer. The green layer here is the emissive layer. This layer is made of polyfluorine that transport electrons from the cathode. This is where light is made. The next layer is the conducting layer, which is represented by orange color. This layer is made of polyaniline that transport holes from the anode. Next we have the anode. Here it is represented by the yellow layer, the second last layer. It is kept transparent, usually made up of indium tin oxide ITO that removes electrons. Last we have the substrate, as you can see. So substrate supports the OLEDs. Next we have the features of OLEDs. First we have the flexibility. Next is lightweight and thin, low power consumption, high contrast, brighter and perfect display from all angles. Next we have the types of OLEDs. First we have the passive matrix OLEDs. Next is active matrix, then transparent, top emitting, foldable and white OLEDs. First, passive matrix. The organic layers are between strips of cathode and anode. The intersection form the pixels. Easy to make. Uses more power. You can see it in the diagram. Next is active matrix. Full layers of cathode and anode. Anode overlays a thin film transistor. Requires less power. High refresh rates. Next is transparent OLEDs. Transparent OLEDs have only transparent components, that is substrate, cathode and anode. When turned off, are up to of 85% as transparent as their substrate. Next is top emitting OLEDs. They have a substrate that is reflective. Foldable OLEDs. They have substrate made of very flexible metallic foils or plastics. Last one is white OLEDs. It emits a white light that is brighter, more uniform and more energy efficient. Last we have picture contrast between a LCD and a OLEDs. As you can see, the picture quality in OLEDs is much better than the one in the LCD. Now we have the advantages of OLEDs. It is thinner, lighter and more flexible. Do not require backlighting like LCDs. As LCDs require backlighting, it do not require any backlighting. Can be made to larger size. Larger fields of view, about 170 degrees. Faster response time. Brighter. Last one is high resolution. Now we have the disadvantages. First one is expensive. Next is lifespan. The lifespan may be shorter. Water damage, that is, it is not waterproof. Next is color balance issues. Now we have the applications. First one is OLED TV. Next is mobile phones with OLED screens. Next is roll top laptop. Here you can see OLED TV. Next is mobile phones with OLED screen. First one you can see the transparent OLED. Next one is foldable one. You can see that it can be folded easily. Now we have the conclusion. Organic light emitting diodes are evolving as the next generation displays. As OLED display technology matures, it will be better able to improve upon certain existing limitations of LCD, including high power consumption, limited viewing angles, power contrast ratios.